Welcome back to our M5 watch along. Again, we are joined by Jay, and we
Hey
are
everyone.
going to continue with our watch project. So I haven't changed too much since last tutorial. I did move some things around, and I hinted at one of the next steps, which is designing a part that represents the screen that we're going to use. Last time we talked about using a specific screen from Adafruit, and we've actually talked about it more, and we found another one that we liked, which I don't have up right now, so let me find it and show it to you guys. It's a full color LCD screen. Let me grab it because I think it's useful to have a look. Here it is, right there. And we're going to use the 1.54 size for this part. So anyways, yeah, we're going to talk about what it takes to design this part and how to integrate it into the PCB, and we're going to get there after we do some wiring because we have some sections to wire. So where do you want to start? You have a preference? Just jump right into the
Let's
power in section.
let's do the power shenanigans. Um,
So we had a reference schematic for this last time that we were kind of going off of.
yeah, do you want me to send you an image of it?
Yeah, that'd be great.
Here we go.
I think I got
There's
it
an
ready.
extraneous resistor that we don't need, but um, it's just still in the Photoshop. Again, this is Adafruit as a reference schematic. We're not like claiming it's ours. This was Lady Ada's idea, I think. Very clever. Um, but
Okay, let me put that up on the screen. Yeah, so what's the point of this circuit? It's to switch between using
so
battery power and USB-C power, right?
yeah. So by having a pulled. Should I explain how it works, or do we just
Yeah,
want
yeah.
to say it
No,
works
go
that way?
ahead.
Okay. Um, so I'm a little rusty on my MOSFETs, but so the idea here is that when we have two power sources, the battery and the bus, the USB connector, both plugged in or both powered up at the same time, we want to default to the uh, battery voltage. Sorry, no, we want to default to the USB power over the battery voltage, and that's because we want to be charging the battery and we have like basically more current than we could ever want to draw from the USB side. So what this allows us to do is default to that. No, traditionally what you do is you use two diodes. You just take the um, battery and diode it to like some V source, and then the bus and diode it to that same rail and use that as your power source. However, there's disadvantages to that. You're going to have a voltage drop through all diodes, as I'm sure you know. So what this little circuit does is it avoids that drop when you're going from the battery to the regulator, because when you're in a watch, low power is everything. So when the USB is plugged in, that VBus line, which is connected to the gate of the MOSFET, um, is that the right term? Gate?
Yep, right here,
Yeah,
pin
was
1.
connected. Yeah, was connected to the gate of the MOSFET. The MOSFET opens. Current does not conduct through it, so the only thing that'll be conducting through it is the diode, which means you have like a traditional diode connection between the two voltage sources. But when you unplug the voltage source from the USB connector, there's a resistor that then pulls the gate to ground and activates the MOSFET, allowing current to flow at little to no resistance, because it's a MOSFET. That's why they're amazing. Um, what that does is it means when you have an unplugged power source, you have little to no resistance between the battery and the regulator. But when you have it plugged in, you have a diode combining the regulator and the regulator source from both the voltage of the battery and the USB connector. Besides being a little wordy, is there anything else I should add, Chris?
No, I think that's it. I think that's exactly the case. So we don't want our positive voltages to be directly connected when the USB-C is plugged in, and this MOSFET allows us to switch between them. So one thing I'll point out is that we're using a 4.7K resistor here, and the schematic you sent uses 100K. Is there a reason for that, or is that a mistake from last episode?
No, that's intentional. So I've built this before for my personal launch project,
Okay.
and I found that while I was programming, if I unplugged or plugged back in the USB, power would dip, um, because it would take the MOSFET too the gate pin on the MOSFET too long to charge.
Okay.
And unless you have like just the right balance of stuff or very low current draw, you'd have a brownout and then your chip will reset, which you don't always want. So by going with a lower resistor, the MOSFET gate will charge quicker and then we will have less of a chance of a brownout.
Cool. The symbol for that MOSFET does look different from the one in the schematic.
It looks a little wrong to me.
Yeah.
Let me pull it up in Eagle and see what pins go where.
I wonder if they are using something slightly different. Looks like this is an N channel and they're using a P channel.
Yes, we should be using a P channel.
Okay, so that's the problem. We picked an N channel.
Oh, interesting. Okay. Um,
So
yeah,
that's all
it
right,
only works with P channel.
right? Because we want to shut off the battery voltage when it goes high. The
Yeah.
USB line goes high. So that's fine. I'll just search that up. It's going to still be a DMG341, and then maybe they have the L variant, just the P channel. No, it doesn't look like they do. What if I just search that? N channel. Here's the P channel, and it looks like the right one, but there's no. Oh no, that's a 315. Interesting. So they don't seem to have it. Maybe we could find a replacement part.
Yeah. Let me see. Any generally similar one? What? Let's pull up the data sheet on the DMG and we'll find something similar on DigiKey.
All right. Just had it a second ago, but if I go in here to my manufacturer part search, actually if I highlight this part and I scroll down, I can get the datasheet right here. Good thing to know. And here it is. So here's the one we have right now. I guess we want the other one, which is the same name, but it has an L at the end instead of a U. Whoops. 341L. Oh, it's a 341. That's strange.
Mm,
That's it.
I have the. We have the 2.3 or the 3.2.
The I'm not sure we have either. This is the one we want, I believe.
I have a different. Again, I'm drawing from my personal one. I have a different DMG on there, unless
What do
I'm
you have?
misremembering. DMG 2305. Or is it the same thing?
DMG2305. Uh, P channel. Yeah, that's it. It's there. So that worked for your
Okay.
project?
Yep, it's what I'm wearing.
Nice. Then it works for ours. And yes, that looks like the right symbol. Cool. Alright, sorry about that little problem with the audio, but it's fixed now. So we were trying to figure out the polarity of this charger, and we have a link now, so we can check this out. Cool. Yeah, so that's what we're going to be using. It's going to be a battery like this with this little JSD connector. So let's just get our information. So it looks like if we go in here, oh, this is a top entry connector.
Ooh.
That's not exactly what we want.
Wait, does it not have does it not have a couple options?
It looks like if I can pull this up on, let's see, that's it on Octopart. Yeah, it looks like this is soldered flat to the top of a board.
Hmm.
So that is not what we
Wait,
want. We want a side-angled one.
ideally.
So let's hop over to DigiKey and look around a bit. There's a chance we'll be making our own part for this.
I don't. Hmm. Based on my looking around, the part we're looking for is not stocked by DigiKey. They don't stock that company that produces this.
Interesting. Okay. So let's look. Right angle JST. It's always something random that ends up being the hardest part to find.
Hmm.
There's a 4-pin version. What's this one? Is this what we want?
No, it's 3. Wait, go one down.
One sec.
No, no.
This is the 4-pin one. Another 4-pin. Seems to be much
Add
more
a
common.
filter.
Okay, number of positions, 2.
It is not in. Oh, oh, maybe. Try.
What's this part? Have we looked at this one before?
I'm
Why
gonna
can I
send
not?
you a link to a DigiKey page. Can you put it on the screen and we'll discuss?
Sure.
Sorry, DigiKey part number.
Would this work? This looks like what we
Uh,
want.
yes, although it is through hole, which is not ideal. We can make that work if we have to.
Alright, let's look at your link.
I think
Alright,
this is what we need. And I think they just restocked them, unless I'm misreading the page.
interesting. Let's try and search this in the manufacturer part search to see if there's a part for it. You can actually just put in the DigiKey part numbers usually, and that looks like it.
Awesome.
And it looks like they haven't been updated that it exists, but I believe that is the right part. Let's
Looks like
place
it
it.
from here.
Let's get rid of this. I want to change the comment.
Oh, it also is available on SnapEDA and Ultra Librarian if we do need to make it.
I think this is the right one. Cool. Alright, well, let's proceed with it. And because we
Awesome.
know it's in stock, I guess you have to be at least a little careful. Sometimes these aren't updated if it's just freshly restocked.
Additionally, this part is available in one that physically matches from Adafruit in singles. Not
Perfect.
a deal, but if we need to, we need to.
So I'll put that there. M5 might even have these. All right,
I
so
I think so.
continuing with our circuit. So did we figure out which one is the positive, which one's the ground for our particular project?
Not by pin number.
Right.
Um, is it hard to switch?
No, not hard to switch at all.
Okay,
Maybe we can
so
decide when we
let's.
get to the PCB because I don't know. I'm guessing
Yeah.
that these match the PCB where this is the left and this is the right since this is the square pin. Uh, but I don't want
Think
to make a
we
connection and forget to correct it if it's wrong.
okay. Um, then we'll just add a comment on the schematic saying blah blah blah. Need to connect.
Cool.
If you
So we're going to place
and
our V bus. Right, so that is the voltage coming through the USB-C. And that connects straight down like that. And then let's pull this down to give ourselves some room. Then we have that diode here according to the picture. Then we have this. We have this is going to actually, hold on, this goes here. And then I'm not connecting this at the moment, but I could at least ground the mounting holes, since obviously those are not going to connect to anything else. Alright, I think I will change this to, say, P channel MOSFET. And if you're using multiple different types of MOSFETs, it might make more sense to put a part number there or some other information that helps you identify what part to choose. But because we are not using any others, I think it'll be okay to say that. You know, because when the DigiKey order comes in and we're going through the different bags of parts, if there's multiple bags of P-channel MOSFETs, I might end up being very confused. But
You'd also say, like, if you do want to have P channel and the information, you can always include the part number in that name as well. But in this case, we don't need to. I agree.
and if I end up being confused at any point, it's not a big deal for me to just come back to the schematic and or my bill of materials and just check and see what it was. Okay, and then so we might want that 10 microfarad capacitor there. What do you think?
Wouldn't hurt.
Wouldn't
You mean the
hurt. And
one for the regulator?
no, I mean the one. Well, I guess all of this is going directly into the regulator, right?
Yeah.
So
We
it's
could just
already
move the
going
regulator
to get
nearer and just
filtered.
extend that line to VIN.
I agree. I think this would make more sense to just connect these.
Might even be clear.
We could do that. And then this is going to go to ground. Are we going to tie enable high?
Sure. I don't picture any scenario where we want it low.
NC means no connect.
Yeah.
Whoops, don't do that. Let's drag this out. And then this also...
Some regulators will have like a PG pin, which means power good, or they'll have like additional functionality and they'll expose that on there. But it would be useful on a watch, but it's not particularly important in this case.
The only question I have is about tying V in high. Would it be okay to just tie it right to the input voltage, or does it want a logic level voltage on the enable?
It should be the input voltage.
Okay, perfect. And this goes to ground as well, so let's ground this out. When I design schematics, I tend to not use extra ground ports. I tend to like try and connect them all to the same one. For me, I think that's clear, but I also think it's kind of a matter of preference. I could make separate ground ports for all of these different parts.
Yeah.
You have an opinion on that?
100% preference. I do separate ground ports. Well, I use labels, but that's up to what you think is clearer when you're designing the circuit.
I just like seeing all of these go to the same place because that is electrically kind of what's happening and
I
what
think
will
you
happen to the
design
PCB.
more analog circuits than I do, which in analog circuitry, it tends to make far more sense to show the connection.
And
as
now that
well.
we've combined those two sections, I'll move this over and kind of center it on this section. Maybe I'll move this over. I just care about the layout. Cool. Okay. So that's pretty good with the exception of this connection, which we're going to figure out later. I just want to make 100% sure that we don't mess up
Should
what's
we add
going
like
on
a
there.
bright red comment or something really we won't miss it?
Yeah. I'll say review connection. And I'll put it there so it looks really ugly, and that way I will not forget to fix it because I hate when things look like that. And I might reduce the size of this to match the other label. Cool. So, moving on. Battery charging IC. Do we have a reference for this?
Yes, 4.7 on VDD to ground. Sorry, 4.7 mic from VDD to ground, 4.7 from bat to ground, and then prog should be that 10K resistor between ground and prog. I'll double check that last statement.
And we said we were going to review that resistor value. Maybe now's a good time to
Yes.
do that. I assume our 3.3 volt, no, our battery voltage is the VDD.
No, the battery voltage is
Oh, it's
VBAT.
VBAT, of course. Okay.
VDD is 5 volts.
5 volts.
Or VBus, sorry.
VBus, okay.
And the reason we're not connecting that to the combination of the two is we don't want the battery to try to charge itself. That
Right.
doesn't end well.
That makes no sense.
We should review the resistor value when we choose a battery capacity and size.
Okay, that makes
Which will
sense.
probably be next episode or two, once we have a model working, or like a visualization of the size.
What is stat?
Stat is an output pin from this IC. It will tell you when it's charging and when you're done charging based on the state of the pin. We don't necessarily have to use it. I think it needs to pull up if we do want to use it though. 10K.
Well, I don't know. If it's just one pull up, why not?
Sure. And then we just run that to our microcontroller. Although a modern feature of many modern microcontrollers is that they have internal pull-ups on the GPIO. So in theory, you can get away without this pull-up because this is not like a boot up critical pin. We don't need it to be pulled in any direction for the device to power up. Although since we have enough space, I'd say let's go for it. We can always remove it.
Sounds good to me. So I will stick that there. VSS is ground.
Yep.
This is getting pulled up,
Pardon my
actually.
clipped English, please.
Right there. I don't want that connection. No. So that happens, Altium automatically makes schematic connections when you put the tip of one part onto the wire, any other wire or any other part. So if you don't want that, don't do it, and move it one space above. And that won't happen, and you can wire directly through it. And now there's no connection there. Just something to think about.
If we're using the MCP 73831, we do not need a pull-up. Based on the datasheet, I'm looking at page 11. The description of the stat pin shows that MCP 73831 has a tri-state output, so we don't need it.
Cool. So we can get rid of this entirely.
And we can just put a name label, I would think. Stat, I guess. Or
Works
bat
for me.
stat.
Net label. I don't think anything else is going to use a status line. So we can give this stat, and I will align it to the right. Put it here, and then pull it out one. Cool. We talked about this. Okay. And then this resistor, what is it doing? I forget.
That is our program resistor. It sets the charge time and current. So we're going to leave it at 10K, which is the minimum amount of current you can charge with for this chip because we don't know the size of the battery we're going to use. And it is a pull down on prog. And speculation would provide it. It forms a resistor divider with an internal resistor on the chip.
Cool.
For anyone who's really curious about how that works, read the data sheet, start on page 11, section 3.5, and then read through and you can find a table elsewhere for the calculations of current to resistor values.
That looks good. Okay, this looks good. voltage divider. This should be really easy. This is just to check what the battery value is. So if we place our VBAT right there. Okay, then this is going to be the, well, we gotta ground to the other side. And then in between these, we will wire them to a net label. And this net
VDiv.
label is going to be, what's that?
VDiv.
I like it. Right there. Cool. And that's that. So now we can see what the battery level is based on our analog inputs. So the RTC, that's another one we're going to want a reference for.
Mm-hmm. Can you zoom in a touch? So SDA and SDL require pull-ups. VBAT should connect directly to VBAT.
The raw voltage, not the 3.3 volts?
Yeah, so the idea is even if the battery runs lower than the 3.3 volt regulator requires to output voltage, the battery here will still be able to draw its minimal amount of current off of the LiPo without having to, without requiring the regulator being on, which means you can have time preserved past your watch being dead.
That's pretty cool.
And that pin is dedicated specifically for that. VCC will connect to 3.3 volts. And that basically means the part of the chip that does interfacing over I2C is powered by 3.3 volts. And then the time that does the part that does the timekeeping is powered by BAT and or 3.3, depending on what's hooked up.
You said SDA and SCL are getting pulled up, right?
Yep.
Cool.
And I'll check about reset. Probably it will, but. So this reset pin has an internal 50 kilo ohm nominal value pull-up resistor to VCC. So we do not need that third reset resistor.
Nice.
So the int square wave is basically an output of the chip's internal 32 kilohertz
Okay.
wave that it uses for its own timekeeping. We could, in theory, hook that up to the main microcontroller. We don't really need to, since we're not going to be running a lot of code on this. We don't need to use the internal timekeeping sections of that chip because it's not too long to make an I2C request for the time. If we were doing like a lot of high processing on this, it might be more efficient to use this clock output as a source for internal RTCs in the SAMD 51.
Right.
That way you don't have to like do the IO call while you're managing stuff. But in this case, it really doesn't matter. Oh, sorry. The 32 kilohertz is the output pin. The int is something we might want to consider hooking up. I had the names backwards. My bad.
So
If we want to,
where's the
if we want to
32
use
kilohertz
this
line going?
32 kilohertz nowhere.
Nowhere.
We'll just
Okay.
leave it not connected. Int will eventually go to the MCU.
Okay.
And this kind of thing, this pin can be triggered on alarm when a register hits a certain value inside of the RTC, or there's some other configurable options. But well, it does require a pull-up. We can either add one here physically, or we could use an internal pull up to us on how much programming we want to do.
I don't know. I feel like if it's already given to us and we're already using it elsewhere, then it doesn't cost too much to copy and paste the same code that's working on stat.
Um,
Because we're
so
doing the
stat,
internal pull up on stat.
no, we don't need to. Stat is push pull.
Oh, okay.
This is not. But we can always add a comment on the schematic saying requires MCU internal pull up.
Okay. Let's do that then.
The worst comes to worst, we budget. Although Microchip has very good documentation on how to use their GPIO system, so I'm sure we'll be fine.
Cool. Alright, I think it's time to start worrying about the screen and start spelling things correctly. I'll do it. Okay, I've got it. How do I want to place that? I'll put it like this. And I will pull this out so you can read it. Okay, I did flip this around. I don't know if anybody noticed that, just because I like having my 3.3 volt line kind of at the top left here instead of sticking it weird at the bottom. All right.
I also notice you do this as well, and I also enjoy it. Having pull-ups have the voltage source at the top, and pull-downs having the ground connection at the bottom.
Yes.
It's far clearer, and it keeps consistency.
Yep. Cool. Okay, so I am going to start making this custom part. So there are not too many pieces to it. It's really just a bunch of header pins. But I'm
Should
going
we
to
explain
use...
what the custom part is first?
Yeah. So hopefully by this point you've had a chance to look at one of the custom part tutorials and kind of have an idea of what this process entails. But just to review it, we want to use this entire screen as one single part. Obviously, it's made of many parts. You can look at the front and back of it and see that it's its own breakout board that comes with different ICs and chips. But we don't care about them, and we don't want to represent them on our part. So all we need are these connections and these mounting holes. So that's what we're going to do. We're going to make one schematic symbol first, and it's going to have all of these electrical connections. And then we're going to make a footprint that has the same electrical connections plus the mounting holes and the space that's going to be required for this to fit mechanically within the enclosure that we design. So that is what we're going to do. And yeah, I think the schematic symbol will be pretty easy. And I'm going to use the master library that I talked about in one of the other tutorials. Basically, this library is providing a source of custom parts to all of my other projects within this group, which is good if I ever want to use this LCD screen again for a different project in my M5 work. So I will open up the schematic library. It's going to take a second. And while we do that, we're going to take a look at what we need for this project. And I believe this is completely breadboard compatible. Yep. And the nice thing about that is that breadboards have standard 100 mil pitch, which means each of these holes and each of these pins are 100 mils apart, a tenth of an inch. And that makes our job incredibly easy when we're designing a footprint. But before we do that, let's just make this schematic symbol. So I'm going to go to, let's see, I'm going to get rid of manufacturer part search. I'm going to get rid of properties for the moment. And I'm just going to have the schematic library, add a new part. This part will be, what is the name of this part? I should put the real name in here.
Adafruit, and then the part number?
Yeah, I should use the board because we're doing the board.
Click on the second link on the right.
Second link on the right. Right here. Yes, that's the one.
Yeah. And then in the URL should have 3787.
Okay, cool. So I'm going to say it's the Adafruit 1.54 inch LCD, and then number, I'll put the number so it's easy to reference later. Yeah, 3787. TFT LCD.
Before we're too far into the schematic, I have an Altium question for you.
Yeah, I just forgot the number again. What was it?
3787.
Perfect. 3787. Okay.
Are you
Well,
allowed to link one symbol to like two possible different footprints?
yes. Yeah, you just add a
Okay.
footprint right here, and that's really all there is to
Oh,
it.
nice. So we could consider making one footprint with mounting holes and one without. For our sake, we're just going to make the one we want. But if you're making like a library managing it, that kind of thing can be useful depending on your user's application.
Yep, that is definitely true. I am going to do the little thing I like to do while I'm designing parts, which is I'm going to get a screenshot of the pins that I need. These are all the pins that we're going to consider, and then I'm going to keep it next to me while I work. Easier than switching back and forth, in my opinion, between programs. So we'll do that. Can I zoom in a little bit? Sure can. Cool. And for this, I think I'm just going to copy them in order. There's not a whole lot to it. I'm going to put this on my other screen so it doesn't block Altium. Okay, let's do it. So, obviously this is different from the last time I designed a part. I need to fix this first. That means the designator needs to be pin 1. The name of it, in this case, is VIN, and it is a power pin. And that's that.
Mm,
The next pin is called 3VO, 3 volts out.
yep.
The next pin is the ground. It's nice, we got all our power pins right next to each other. Okay, now this is different. This fourth pin is the SCK, and the SCK is an IO line.
It's an input line.
That's true, I should actually change that. So we're going to say, yes, the MISO is an output line. SCK is an input. Nice catch. MOSI is also an input.
And
Seventh
chip
pin,
select is an input as well.
TFTCS.
TFT chip select. So this board has for all the viewers, this board has a micro SD card and a TFT on it. And what's really cool about micro SD cards is that there's a mode where they can just basically speak slowly over SPI. So it only takes an extra couple pins to get that to work.
Okay, reset. I guess that's an input actually. Then we have our DC. What does DC stand for?
It stands for data or command, if I remember correctly.
So that's an IO.
No, it's an I.
Okay. SDCS. By the way, if you're doing this work and you don't have a J next to you to ask these kinds of questions to, they're all available in the datasheet for the part, or in the Adafruit tutorial, or on the Adafruit webpage. You just need to dig around a little bit, but the answers to these questions do exist online, and I would be referencing them if not for time considerations and the fact that Jay is right here and knows these things. So SDCS. I've never used this part before.
So I used similar displays. SDCS is the SD card chip select.
Cool.
Um, I find it a bit of a cryptic name. I think they use that name because they're running low on space.
Yep.
We could change it if we wish to, but I'd say that's something you can always do when you want to enhance your library.
Light.
But that is an input. Light is an input. It's an analog input,
Interesting.
and that's basically a pulse width modulated signal that goes to a transistor.
And then it looks like the
I
last one
think
is
it's
TE.
active high. That's an output actually. So TE stands for, I think it's tear enable. This I see in the display will say, hey, I'm refreshing. If you change my data, you might see tear lines. So often if you're going for like high quality projects, you'll hook that up to your MCU or your FPGA and then pause outputting until that's done.
Interesting.
In our case, we might hook it up, but we probably won't use it.
I just accidentally made a different part on this. My bad. Okay. I meant to click this. Nope, this. And get a rectangle because I think for this, usually in my schematics, I try and make the symbols as small as possible. But I want to make an exception to this rule and have a slightly bigger than necessary rectangle.
And it's to represent that it takes up physical space.
Yeah, and also to make it, we have a lot of room on this schematic. So I feel like if I want to quickly identify the parts of the schematic or have someone else do the same thing, it just might be nice to have this thing that says, TFT LCD, 1.54 inches.
Do we want to put the driver IC on the schematic so people can reference what datasheet they should be looking up if they're software people? Or
Sure.
is that... Okay. This is an ST7789.
I think I'll actually rotate this. It's a, sorry, what was that?
ST7789.
And I'll stick that right below it, slightly smaller font. Cool.
Nice.
And actually I'm gonna right align both of these so they line up with each other. And then I'm gonna move them over just a little bit, and I actually might change my grid to 50 because I like them right there. And you know what, I'll include the Adafruit part number just so it's really easy to find. Copy, paste, and this is Adafruit 3787.
Yep.
Whoops, looks like I switched those around. That's okay. Okay, and I think that's a pretty nice symbol. And I forgot this
Agreed.
is a 50 mil snap. So it should be easy to figure out what this is for. Cool. So that's it for our schematic symbol. Now we can move on to the footprint. So this is the bigger challenge and the more, I'm not going to say more important challenge, but it is important because if you get this wrong, your PCB doesn't work. I guess that's true of the symbol as well, but so let's look at this. So it looks like we have to choose whether or not we want to go, well, it's actually, the display is a square, but the question is, do we want all of these lines to be on the bottom or on the left, or how? I think on the bottom makes sense.
When we were designing the footprint,
Yeah.
I would go with...
It kind of looks like it wants to be oriented this way.
Yeah, that is how the board is oriented. The screen is actually upside down on the board, but that might not be important.
I assume that it's pretty easy to have the display flipped.
Yes, generally. If you're using a library, it's normally one line of code.
Cool. All right. So you want to put these on the top? I guess that doesn't make too big of a difference.
Sure.
Okay, then let's do it. So what's a good picture that shows us the top view? Yeah, and it will go like that. Okay, so put these right
Can you
here.
rotate in your Windows, the software you use? Can you easily rotate?
I think I can. But first, let's set up this part. I think. So you said you were gonna open this in Eagle, so we could look at the
Yes. Let me
dimensions.
pull it up.
So this is going to be the same thing. I'm probably gonna give it the same name.
Okay. pulled up. I'm also, give me a second. Okay, I can also give you the pitch between the mounting holes.
Oh, don't forget to set your designator. Just gonna put that out there. And I'm gonna move
What kind of
this.
designator would you use for this?
I've been using B0 or
BRD?
sorry, BO for breakout.
Okay.
And I think I'm gonna put this Adafruit identifier as either as a comment or description. I think I'll use it as a comment and I'll just hide it, but I'll stick it there. Cool. And then I wanted to copy and paste this. So this is going to be our name for the footprint as well. That's not generally what you always do, but I think it makes sense. And I'm going to, so first of all, I want to notice right down in the bottom left that my grid and coordinates are set to millimeters. Since we know this is a 100 mil pitch between these, I can hit Q on my keyboard without selecting anything. Now I'm on mil, then I hit G, and then I hit 100 mil, and I can start placing pads. So click the pad button. I've got a pad right here. Let's make sure it's the right size by hitting tab. I can tell you it's not the right designator. So I want these to line up like I did last time. I need one to be my VN. So just keep that in mind when you're orienting these.
Do we want one to be the VN?
If I want my designators, my pin designators to line up, then yes. And I think that I do.
If the pins are at the top, we want the top left pin to be TE.
We can
Flip them easily.
Yeah,
We
I'm
let's
kind
just
of.
do them on the bottom.
You know what? Yeah, I'm kind of tempted to do them on the bottom and then rotate the part later when we actually make the PCB.
Sure.
And I think that is what we'll do.
If it makes it easier to design and prevents less stupid errors, I'd say let's go with it.
Yeah, I think that is the right play. So let's make sure this is the right size. Looks like it is. Yeah, 40 mil. So this is like your standard through hole. Cool. This is the one I use for most. And so all I have to do is hit the right arrow on my keyboard, and I have my perfect 100 mil spacing. So that's the 3 volts out, ground, SEK, MISO, MOSI, TFTCS, reset, DC, SDCS, whoops, light, and TE. So that's 12 pins. Let's make sure that's exactly how many pins we want over here. 12 pins, yes, 12 pins, good. Awesome. Now I need to think about the mounting holes and the area that this board will consume. So do you have some information about that? Maybe you can share your screen for a second.
Sure. Let me just turn on some visual settings before doing that.
All right.
Okay.
So now we're looking at Eagle. This is an alternative to
Yeah.
Altium.
We're looking at the back of the board. Lady Ada, Miss Lemore Freed, tends to design her boards with the components she's working with on top. So we can check the coordinates of these holes, and her 0, 0's right here. Oh, can you see my mouse?
I cannot see your mouse now.
Okay, let me switch to the select tool. So her 0, 0 is where this white box is, that origin sign.
Ah, okay.
But we can extrapolate the positions of things. So let's start with this then. Let's measure the distance from here to here. So I have this grid on a, let's check, 10 mil setting, and it looks like we have,
And this is done in mil, not millimeter, right?
yeah, mil as in 1,000th of an inch. I'm going to bring it down to 5 so that we have an alignment with the center of this pin.
Okay.
I counted 15 ticks, but we can also just check the length of this line. So it looks like it is. Wow, my brain's having trouble with math today. 75 mil long. So from the center of the pins to the edge of the board, we have 75 mils. And then we can extrapolate from there here. I'll measure the length from the center of this pin to, to the edge of the board that's inside the indent, if that makes sense. So
Yep.
I'll measure this and then get back to you while you work on starting the board outline.
So jumping back into Altium, we knew that was 75 mil, so we need to, mine is rotated. I could rotate it to match Jay's display, which is what I think I'll do, just so we can make sure I don't make any stupid errors. And for now, I'm going to hop into my top overlay, and I'm just going to place a line that represents the edge of the board there. So I need to change my grid snap to 25 should be good. Now I can go 75 out. Okay, so I know the edge of the board is going to run this distance in some way. And then what happens next, we're waiting for Jay to let us know.
Okay, so I have the distance from the TE pin to the edge of the indent, if that makes sense. So like if we were to cut off the holes, I have the
Yep,
distance from the center of the TE pin to there.
good to
That's
know.
65 mils.
65, interesting.
Yeah. So I'd say let's start with like drawing that, and then we can draw the actual dimension lines later once we have all of our stuff notated.
I just
That way
set
we
the
aren't like, oh, nice.
yeah, so what I want to do is hit G, go into my 5 mil, then I want to hit this. So some people might be wondering why I'm doing this in the top overlay. Seems kind of random. There is a reason for that, and the reason is it's really, really easy. First of all, I do want a top overlay anyways, because I like having an overlay of the general outline or area of a part. So it is going to make it into the final product. It's also really easy to draw your mechanical regions once you have a rough shape outlined by literally anything else. So what is the width of this? Because apparently it's not 10, it's 7. Okay. It's kind of small, but it's probably fine. JLC should
We're
be able
probably
to
good.
handle it. So 65, you said?
Yep. I have a question. Your holes look a little small. Um, is that because they need to be adjusted or?
Yeah, I actually kind of just accepted that as the correct diameter. These are round holes with 40 by 40 mil, which if you convert to millimeters, then you get 1 millimeter by 1 millimeter holes.
Okay.
Oh, wait a second.
Let me pull
That's
up.
not what I want. You're right. It's a 1 millimeter by 1 millimeter pad and a 0.6 millimeter hole, which is too small. The hole should be 1 millimeter, and I believe these are 1.5. I
Do
think
you
that's
want
right.
confirmation of that?
Yeah, if you could double check me, that'd be good. I've looked this up before, and I think that is ended up being like sufficient.
I'll just open my library. Do the quick and dumb way of telling you. So I have a drill diameter of 40 mils and a overall diameter of 70 mils.
Yeah, I believe that is pretty close to what I just said. I think you have a pad diameter that's a little bit bigger than mine, which is fine. I kind of like that for this. Yeah, I have a pad diameter of
Four things.
60, so let's go
Okay.
70. Why not? Makes everything a little easier to solder to anyways. And yeah, the 40 should be the same. Perfect. Yes, let's continue with this top overlay. So I assume that it's the same on the top as it is the bottom. This board is
Uh,
symmetric.
Assume that is true, and I will check it while you're doing it.
So this will go up to 1065, like that. Cool. And then I can extend this line out to be the same as that one. Connect from here to here. And then that should be good. And I want to actually use less lines is better. Becomes easier to edit later. Cool. Okay, now we need the length of this entire thing.
Oh, 65 might have been the wrong number. It might be 85. I'm gonna go double check that.
Hmm.
Which is weird. They should be identical. I'm guessing it's an issue between the keyboard and the chair in my case. No, I'm reading. Let me delete some more things. Some of the measurements.
Maybe I should put your screen back up while you... It's back on the recording now.
Okay, so see how I went from the center of this pin up and over?
Yep.
I did the same thing down here. So I'm going to check this for properties. If we have a Y difference of 65 and 0,
Cool.
which is obviously 65, but here we're still aligned with this dimension line up there.
Yep.
We have 1250 and 1165, which if we do the dumb way of calculating, is not 65.
Interesting. Okay. So it's not perfectly symmetrical.
Yeah, I mean, that's one way of doing it.
Is that what the length thing was doing?
What length thing?
Nothing. Okay, so that's fine. That's easy to change.
And this might be one reason why it's good to draw things as a silk screen layer before dimension layer. It's easier to modify that when you're not, you know, locked into that, locked into a contiguous dimension
Can you get me
line.
the length from the center of the VN pin to
Mm-hmm.
the left edge of the board?
Sure.
Yep.
Here we go.
Length 1650.
It. Yep. And to the thing you just said, yes, it is. I just wasn't looking at that.
Well, that's okay. So if I grab this and I hold it so it's floating, I get the coordinates of the center of this, which I can now up
Are you
to
showing your
85.
screen?
Yes, I am sharing my screen.
Okay.
So now that I've got that, now I can do this trick where I take this. This is going to show me the position of this left edge. Now I can go 1650 negative. Probably should have just dragged this out, but I'm going to hold on to this left key until my bottom left. So I'm looking at the bottom left to get that length, x colon negative 1650. And there it is. Cool. So now I've got that far edge. I can now pull this out and do it the correct way. And that's much faster. 1650. Very cool. Now I connect these with one line. And we've got the very general rectangular shape of the board. Now we can worry about our mounting holes. Alright. So the X offset of the mounting hole from pin 1 and then the Y offset would be good. Because right
Say that
now
one
this
more time.
pin 1 is 0, 0. Right, so what we want is the X and Y offset of the center of the mounting pin. Basically the location of that mounting hole. Can you select the entire hole?
Yes, I can. But you just want the distance from the center to center?
Yeah, I
Or
want
do you want?
those. Yeah, I want exactly what you're drawing right now.
Okay.
Although, actually, you know what I just realized? I almost made a mistake. You're looking at pin 12 on the bottom. I'm looking at pin 1 on the bottom, which means I need to select everything, then hit
And flip
Y
it.
and flip it so that it's the same, which means that 85 number is actually the wrong number. Right, so I need to go up, up, 65 here, and the 85 is on top. Cool. Okay. Now we are on the same page.
Literally and figuratively.
Exactly.
Okay. So, oh crap. Let me delete this. Okay. And again, this is the hacky way to reverse engineer things, but it is also fast. So we have a length of 165 mils down and
165 mils down, and how many mils over?
25 to the left.
25 to the left. Right there. Whoops, what happened here? Hold on. We're going 165 down and 25 over. Cool. Need to click twice. And then I can right click, and there it is. So that's the center, is this left dot here. So what I'm going to do is actually place another pad here, and I'll just change the size of this pad until it's appropriate. So what is the size of that mounting hole? That's another question.
Working on it.
And we're actually going to call it MNT, which is the mount. Or I could call it ground, so that it's connected to the
Call it
ground.
mount. Call it mount. And the reason we could call it mount is because on Adafruit's stuff,
Yep.
they don't ground those holes. So we could, in theory, pass some other signal through it. Should we? No. Could we? Yes. And that kind of thing will vary from company to company. Often, some companies will say when you have a schematic, or when you have a symbol for a schematic, only have one ground pin, and then whoever makes that symbol and that footprint has a responsibility. Other times they say break out every pin to one symbol pin, and then it is the responsibility of the schematic user to do that. So that'll depend on your preference or where you're working. Um,
And allowing,
the drill.
not grounding something like that is good because that allows you to do stuff like we were talking about earlier. You could, put a screw through the mounting hole and have that screw be, capacitive touch enabled or something crazy like that.
Yeah, and while we aren't doing that, if any of you want to, make this or practice, that would be a great thing to add to this and like see how modifying a design would work if you're interested. So we have a drill we have a drill diameter of 100 mils, and
100,
the diameter of the pad is 140.
140 by 140.
Would you like the diameter of the little jut out?
Yeah, that'd probably be good to know.
Or actually, we can just give you the width because we know that that's the diameter.
So I'm going to
Um,
use the arc tool now. I'm going to use the center, line it up with the center of this, and then, well, I guess actually I don't need it because I know that it's going to line up with this, right?
yes, it does, but we're gonna do an idiot check. It should be 200. Once you line it up, go back, double check.
So now in the bottom of the middle, I can see my angle that I'm sweeping, and I can try and get as close to 180 as possible, although it's not going to be perfect, and it doesn't matter. This one should be pretty close to 360. Actually, it's exactly 360. Now the radius is 100, so the diameter is 200. That's great. The start angle is going to be 180, like we said, and the final angle is 360. And that's it. So now I can connect this.
Can you check the diameter for?
Diameter is 200.
Perfect. Did you already say it and I miss it?
Yes,
My bad.
no problem. And let's make the width the same as everything else. So the width, we said we'll do 7. And now this, we can actually pull this edge back a little bit. Oh, or maybe we can't because there's a line there. And if I bring this forwards so that it's in line with that one, and look at that, we've got our cutout. I keep making new lines when I don't mean to. Okay. So the question is that perfectly symmetrical across the center of this, or is it not? And what happened
Doubtful.
to pins 6 and 7 got put together? So that's not good. Okay, so what does that mean? That means that I made a mistake, and I have to go back and fix it now. This goes 4, 5, 6, 7 on the same thing, then to 8 is because I hit enter twice when I shouldn't have. Is it a big deal? Not really. We delete the top of this. We remain calm. We set the grid snap back to 100. Right there. I'm going to select 1 through 6. Should have done that before I changed the snap. And then we just need to add in that 7th pin. So if I copy this from the center, and then I place it, that doesn't look lined up. Hold on a second. Where is this? Ooh, that's offset by 5. Why did that happen? So that's set to 400, which means this should be 600, and at 500, this would go here. Okay, that looks right. So this is 500, this is 600, this is 700. Okay, so I've got it lined up now. All right, so what do? I go back here. One trick that I like to use, first of all, let me set my grid back to 5. By the way, to get the center of these, I'm clicking on them and just holding, and that's all you have to do. So we know it's going to be 85 above. So if that's the case, then we're going to grab the end of this so that it's lined up again, and I'm going to hit E. Then I'm going to hit set reference to location. I could set it to pin 1 actually, since this is pin 1. So now this is my 0, 0 at this point. So this actually is lined up with y equals 0. And now I can move it up 85. That's it. And the same thing over here. I want the end of this line to be in line with that one, so I'll move it up 85. Cool. Now I can connect them again, and the problem is solved. All right.
Okay. So when it comes to physical stuff, I'm going to continue insisting on idiot checks. Can you check the length of the line you just moved up 85? The one you're about to connect to?
Good idea. This line right here.
No, yes.
And it doesn't count
Yes, that.
the tab.
Yeah.
Yeah, the length of this line, so what I can do is hold, press on it, then I can tab, and it says the length is 1250.
Perfect. That's what I have over here.
Awesome.
Okay. Ready for the top right mounting hole?
So my guess is that I can copy and
Oh,
paste these.
the holes? Or
Um,
the, oh, yeah. Yes, that should be true. We should double check. Or rather, I will double check on my end. Proceed as if you can, and then if not, we'll correct.
so I'll multi-select all of these parts, click and grab, move
Actually,
it to
no, that's
1.
not true. It's not. Oh,
Disaster.
is it? Oh no. Oh, fudge. Uh, I'm still doing checking. Do still continue in that manner, please.
Will do. And then I can copy and paste this mount hole. We talked about this in a different tutorial. When you go to copy something, when you're in a footprint or PCB editor, you get a crosshair for the copy. And that might be confusing because you've already selected the object, but what you're doing is setting a reference origin for that copy. So for example, if I copy from the center of this, and then I go to paste, I'm pasting with my crosshairs in the center. But if I copy this part and set my crosshairs over here, when I paste, I retain the offset. That's actually a really useful tool. So keep that in mind. For now, we're just going to use the center, but there are times, for example, when I might want to copy several things, and I don't know where the middle goes. All I know is where the end should go. So when I paste them, now I have the end as my reference origin. So I'll come up with the center of that, and it should line up with this. Whoops. Click. And there it is.
Um, you're good to go for the other two.
Cool. So the distance, the only thing I don't know is the distance from the center of this to the center of the other one on the x-axis.
It'll align. Oh, okay.
So let me set my
Do you
reference.
want the distance? Do you want the distance from 0 to
Oh, no,
that line?
they line up with the end. Never mind. Yeah, so if I set,
Well, actually, let's check the length between the two sides of the board, between the rightmost and leftmost, before going all in on aligning those.
yes, you want to double check the distance?
Yeah, the horizontal width of the entire board.
If I hit Control M, I get a measurement tool. That's good to know. And then I can measure this distance right here. And it's going to give me the length of this line, so I want to make sure first of all that I don't move it up or down at all. So for example, I want to be aligned with y equals negative 1350. I want to make sure I finish with negative 1350. Yep, and I do. And that gives me a distance of 1,725 mil, which
Perfect.
is exactly what you have. Now I hit Shift C to clear that measurement. Otherwise it'll stay there, which I don't want. So Shift C, and there you go. Another good tool to have for double checking things. That works in the PCB editor too. Almost everything that works in the footprint editor also works in the PCB editor. So I'm going to copy this, and then I'm going to paste it over here, and obviously I know that these points need to line up, and they do. And then I can grab this line and fix the end of it, although it looks like it's not as easy as just grabbing and stretching. That's okay. It wants to make new line segments, so I will delete those extra ones. And let's extend this line here, like that, and extend this line here, and then I'd say we're almost just about done. You cannot always just use mounting holes as pads. So there are limitations for some fabricators or fabrication houses where they won't want you to use holes that are too big. They're not willing to drill holes like that, and they'd rather mill the holes. So you need to do something different in that case. It'll depend for different manufacturers. The trick in that case is to define a circle shape as a hole cutout instead. So you would draw a circle, and then the PCB editor you can do a hole cutout for that. But for this part, I think this will actually just be fine. So there is the footprint of our part.
I want to do one last check.
What's that?
So, are you looking at the top or the bottom of the schematic of the part right now?
This is a top-down view.
Okay, so if that's a top-down view, then the side which has a little more space should
Oh
be
no, this wouldn't be a
on
top-down
the
view.
bottom.
This is not a top-down view. This is a bottom-up view because this is aligned with the right. Yes,
Yeah,
this is a bottom-up
and
view.
TE is pin 12. So, do you need to vertically flip it?
I could, or I think, yeah, I would vertically flip this. That's right. And then I'm going to align
So,
my origin with pin 1.
did you already do that, or
Adjusted.
okay?
Set reference to pin 1. Okay, yes, that's very important. If you don't flip it, it won't work. So now we have pin 1 at the bottom, which is what I believe Adafruit has as well. Let's double check that. Yes, pin 1 at the bottom. I'll draw a picture in here. So if I were to rotate this to the side, right, pin 1's at the top on the back view, and it would be at the bottom in the front view. There it is right there. So we're good to go.
So something. So if we were dealing with a board that didn't have the screen right out to the edges, so to speak, I would often take like a silk screen or a document layer and draw the outline of the screen so that whoever's building the board with this can say, "Hey, oh, that's what we need." Um, we're also making an assumption here. We're making the assumption that um, the mounting holes we are going to use on our PCB are the same holes that we want on the are the same holes that are on the Adafruit PCB. Now, for our construction case, that is true. In other cases, you might need larger or smaller depending on how you're mounting.
Should we number the mounting holes actually, 1 through 4, and then have them in the schematic symbol?
They should be in the schematic symbol. Do you need to number them?
I think it's worth it. Just because.
Yeah, fair enough.
So how are we going to do this? So this goes top to bottom, so I guess this one is closest to pin 1. I'll call it mount 1. And then I'll go around clockwise and name these mount, mount 3, and then mount 4. Awesome. And then I'll say, oh, so we should go into our mechanical layer. Technically, there's more we would do here to make this, a proper part. You might think about doing keep outs or something. I think for me, I'm going to be happy to just hold this. We want a fill, I believe. And then we're going to just fill in right here. And I'm not going to fill in the mounting hole area because it's already silk screened and because it's kind of a small part and I don't want, I might choose to put mechanical things under the mounting holes or something like that, spacers or something. Is that a region I want? Hold on,
What did
maybe
you just put on?
I'm trying to put hold on. Maybe I'm looking for a 3D, whoopsies, extruded 3D body. So we have the option to put a height on this. Do you want to do that?
For the display?
Yeah, for the display or for the actual breakout board itself. Although it will obscure the board under it if we try and look at this under a 3D view. So maybe that's not a
I
good
think
idea.
we shouldn't. Especially since we have not determined the height of the mounting standoffs and exactly what we will be using to connect between the boards.
Yeah, I think you're right, actually. The other thing is that
What we could do is add a.
we don't necessarily want this part to represent the actual breakout board. This part could represent a socket for the breakout board, in which case it wouldn't have any 3D body in it.
I agree, and we might end up modifying these. We might change the hole size, etc., depending on how we choose to finally mount it. What we can do is add a label in silkscreen that says like part not finalized or something like that, so that we know we need to go figuratively cover our behinds before fabbing this.
Part not finalized. Put it right
And if
there.
you're in a company or something, you'd say talk to law name or like employee ID. Not that this is the official way to do it. This is just a hacky way to do it.
I'll go with capital letters there, and I think I'm going to use just the
Or do they have
typical
Comic Sans?
default. They actually do have Comic Sans. You can import any TrueType font. By the way, this is a good point. You can make your own TrueType fonts that have pictures or images or logos on them, and then you import them as a TrueType, and that's how you get vector graphics onto your board. You can also download TrueType fonts from the web, and then you have access to them here. I do that sometimes. It's how I got pictures of a reindeer on my Christmas ornament PCB. So something to think about. You can really leverage the TrueType capabilities of the silkscreen layer, but I'm not going to do that for this particular
Awesome.
one. I think for this one, I will just give this a text height of, I don't know, that's a little too big. Maybe we'll go 60, and I think that's fine. And then I'm going to align it with the center. Whoops. Like that. And then we'll put it here. Yeah, okay. Well, I think we should tie these together and import it into our schematic, and then maybe that'll be the end of this episode, which has already stretched on for hours. We'll probably cut this in half before we upload it.
Yeah, or we could just tie them together. Importing into the schematic is relatively easy, isn't it?
Yeah.
Okay. No, let's just play it by ear too. I'm gonna
Sure.
grab some water while you do that. I'll
I'm
be
going
right
to
back.
make the mounting holes too. So if I hit tab, designator, MNT1, like that, and then I'm going to call this, whoops, Oh no, that's fine. NT1, and actually in this case I'm gonna hide that because I don't think it's important to have the same thing twice. So this is gonna be a passive pin, and I want to change my snap to 100 again. There's 1, 2, 3, and 4, just like that. Maybe I'll switch this around. I'll hide the designator because I think I like that better. So I will unhide this and hide this and move this up and change my snap so I can place this where I want it. 1, 2, 3. Okay, so what's the next step? How do I get this into our schematic? The way to do this, save all. Let's check to make sure. Yeah, I want to make sure this. There we go. So now these are connected and everything else is good. Okay, okay, there it is. This is interesting. Footprint not found. There we go. Just forgot to do that. And I get rid of this footprint not found thing. There it is. So we've got it. We hit save. We come into. Yeah, so before we can go back to our main schematic, we need to right-click on this master library, and we will compile the integrated library. This will incorporate our new footprints and parts, so we can use them in other projects in this project group. There we go. We do have some errors. Distance between point 1 and point 2. These aren't errors, these are measurements that I've made. Yeah, that was a measurement I made. It's just when you compile, I guess it spits it back to you. Interesting, good to know. So let's go back into this main schematic, and now I need to go find the components block right here. Give that a second, and we're going to go to master library, and there it is right there. Right click, place it, and boom, we're doing good. So how do we wire this up? We're going to talk about it more in the future. For now, we already decided that it makes sense to ground these mounting holes. By the way, a quick way to do this is to pass one wire through all of these. Since it's going through the tip of the pin, it'll create a connection, and then you can just simply grab this wire and move it over, and you'll get extensions off those pins. Good to know. What else can we do? We're going to ground the ground, of course. Whoops. I wanted to just move this one over. Yep, let's ground that ground. I'm going to use a separate grounding, so I don't really want to wrap around this part. I think that'll look distracting. V in, I think we decided we could use 3.3 volts, but I'm going to check that when Jay gets back.
We can.
We can.
We
Perfect.
should. And we want to leave 3VO unconnected.
Yep.
Otherwise, we'll be backfeeding the regulator. And let's leave the rest of those
I mean, I can
as
just
is for now.
name them SC. Nothing
Yeah.
else is using SPI anyways in this board, right?
Yeah.
So I can just name this SCK, MISO, whoops, MISO, MOSI, and then TFTCS, I guess we'll just keep that the same too. SDCS, I don't know if we're going to ever use the SD card, but I guess, you know, why not? Maybe we might want it for a cool background on our watch. Reset, that's a good question. LCD reset, I could do LCD RST.
We need that. You can have spaces and label names.
You can, although I don't think that's probably proper form, so let's go ahead and just put a dash between them. DC, I forgot what that stood for.
Data control, just call it DC. Sorry, data command. Just call it DC. LCD DC maybe, but
Sounds good.
and the reason it might be better to say LCD DC is because DC could be used for other abbreviations, and DC also stands for direct current.
Right.
We're just avoiding ambiguity.
So light,
TE we don't need. but light we do. And let's add some comments for us to do next time we're on here, saying,
Yeah, that'd be a good place to end.